Yeah, the challenge is how to integrate the partners and the technology through the partners. We see that we are in very early stage of the chain, so our challenge is how to prove and engage the chain to develop new technologies. These can help bringing new materials, new solutions, exchange knowledge, exchange challenges. So that is the way that we see. Is very challenging because we need to put together materials companies, OEMs, energy companies, also government, other auto parts suppliers. So the challenge is how to put tech companies, how to put everybody together to discuss these challenges and bring in new solutions.
Produce these better
Yeah,
batteries?
we are in the very beginning of the value chain of the battery business. We are raw materials suppliers of niobium, and niobium so far, it's a very interesting element that it's being discovering these days. Yeah, for batteries, recent, I would say in the last 5 or 6 years, we've been addressing very aggressively this market in order to really develop a new battery materials chemistry containing niobium. We are very fortunate to find very good partners around the world. Yeah, we are addressing pretty much what is necessary in terms of making, yeah, safer, yeah, more, yeah, high power, fast charging type of batteries, and also energy density. And we are working with cathodes, anodes, but so far the most successful development that we've been doing is we've been partnered with some Japanese company, Toshiba, in order to develop it's already in the prototype phase, a new anode material, which is capable of fast charging. So we are pilot plant now, the production in order to really start to test the market and the OEMs. And we will see, because I believe we will be the first solution in terms of fast charging at a larger scale. So in order to really, I think the biggest challenge is to drive the cost of the batteries. In order to do this, of course, the battery chemistry is very, very important, especially.
So we have partnered with an American company in order to address the first point, the chemical side of it, and also the build and the testing and validation of the module. But then
my dream, if I can ask whatever I want, would be that someone does what Moore did with the silicon for the microchips with batteries. It's a chemical problem. So someone will discover, the use of niobium for batteries, something doing, and you will probably Roddy Basso from McLaren will do that with their batteries. Someone has to do it, and you have a battery that lasts, you charge your phone once a year, or you charge your car after 5,000 miles. That's my dream.
Yeah, the question is how you're going to develop a better materials chemistry in order that you can accommodate eventually that will happen, the fluctuation of the price of the raw materials, because recently the cobalt price went to the roof. So how the industry will accommodate this in order to keep going, delivering the price of the battery in order to really make this technology, the first option and for the consumers in the end of the day. So
it's very exciting what's happening, and I would say CBMM is actually positioned as a leader in redefining the chemistry of the batteries of the future.
Yeah, the limits I think in these days is we want safer batteries, high power density, fast charging, high energy density. And everybody's looking for the perfect solution that brings all those things together. I think most of the scientists and even the startup companies in the Silicon Valley, they are all looking for all solid state batteries. And this will be very thin batteries with safe. It will give you a lot of opportunities for you to miniaturize batteries and to cut down the volume. So for vehicles designer, will be very nice. Instead of having a heavy pack underneath your vehicle, you have a much smaller and lighter type of battery.
So we see that autonomous can improve the safety, and also together in combination with better materials can be a good case solution. So we've been working as well in the future of sensors, how can help this to the autonomous driving. We are learning with big OEMs as well how we can implement it in our facilities, and also how can we develop products together.
2 years ago, we made a completely new bike out of steel niobium for the first time, with integrated batteries inside the frame, and it's a small different philosophy with magnetic region rear brakes, and to enter the low-cost market, but we could not find suppliers to match what we needed. Either they asked for a huge volume, which we didn't have it yet, to modify their production, or we could not find the right parts. So we struggled with production. We basically made 200 handmade ones.
One thing that we've been working quite a lot, for example, is the discussion and questions that raised to us, okay, in the future when we're gonna reach level 5, so the car can be made by paper. And then we do not believe that, because we see still a brand behind that. You still have to protect the consumer. For sure, the combination with better material, advanced materials with AI and also autonomous driving can be a very good combination to reduce fatality. So we've been playing quite a lot in regions like South America, China, and India, how we can reduce the fatalities in the world. And one of the matter is how to improve the material, real material in cars, trucks, buses, and also in bikes. And also creating the mindset of the consumer driving better. Yeah, this is the challenge that we have been working around the globe. And the challenge is lightweighting is something very important, and it is one of the equations that niobium alloys can help. So improve the strengths and then reduce the weight of the performance. So it's one of the projects as well that we launched in Goodwood together with Extreme E, and the body in white, showing the case that it was lighter and safer. And then improving the crash test performance. So it's very important as well, because we still have regions in the globe that we have a lot of people dying because of car crashing. So it's very important to improve the safety. 80 million production yearly, we have a huge challenge to improve the sustainability, the emissions, and also to improve safety. That is all about niobium strategy is working in these terms to improve it.
Extreme E is a new championship that will take SUV electric cars to the most remote, extreme, and damaged corners of the earth. And the partnership with CBMM Niobium is key for Extreme E, because it adds an element of technology that will help do better materials for the cars of the future. Those cars will be electric. Many of those cars will be SUVs. So it's a great partnership that has common objectives and common values between Extreme E and CBMM.
Formula E is the perfect test bed for advancement of EV technology on a global scale. It's one of the reasons why NIO as a manufacturer is involved in the sport, and everything we're doing within the context of Formula E is about the advancement of EV technology and how that translates in terms of what we're doing with our mass-produced cars.
Motorsport's always been at the front edge of technical innovation, and then that bleeds down into road car development. That started so many years ago. The advent of seat belts or ABS, or for us within Audi Sport, it's really been at the heart of what we do. It's part of really our DNA. And now here with e-tron and our electrification, then we were racing 1 year ahead of our first ever battery electric vehicle actually being produced and available. And so therefore we were doing two things. I would say we're telling everybody we're coming, but also we're developing the technology behind the scenes as well.
It's very important because we see the challenge of reducing CO2 emission, improve safety, and also having better performance. All these three main pillars bringing us to thinking about new materials, new solutions, new ways of doing things. So we are thinking about lightweighting for vehicles, commercial trucks. How can we reduce the weight, improve performance, and improve safety? Also the new batteries, how we can have a fast charging and a better life of battery as well, electric engines, sensors. So all these things is gonna come in our short, medium, long-term innovation roadmap. So it's very important for us how we develop stage by stage on this. I could say that lightweighting and safety, we are working very hard. We are working new technologies for batteries, sensors, and also electric engines. That is going to be more medium long term. But everything is the same package to build our roadmap of innovation.